Hello, ladies. It's Mr. Sullivan. We're actually going to take a pause from proofs for the next for actually quite a while. And what we're going to do is we're actually going to be looking at the algebra of triangles. So we're going to be looking at side lengths, angle measures, all that fun stuff. He's going to give us a very good, deeper understanding of what we're actually covering and going over. So one of the things that we're going to be looking at right now is we're going to be looking at the algebra of triangles and the relationships that are taking place in our figures. So today's learning target is I can use the properties of triangles to identify triangles and apply them to find the missing side lengths and or angles. So this is actually 2 lessons into 1. So the first thing we can do is we can actually classify triangles 2 different ways. 1 by their sides and 2 by their angles. And we can mix them together. So the first thing we're going to do is classify triangles by their sides. So if you look at this triangle right here, my side lengths are 13, 9, and 14. So I can see that I have no equal sides, no equal angles. So this is a scalene triangle. So no equal sides or angles. In my second image, I have side lengths of 6, 6, and 8. Well, I see that I have 2 sides that are congruent to each other. So I'm going to write that down. 2 equal sides. And when I have 2 congruent sides, I have an isosceles triangle. Now, in our last image, all my side lengths are 4, so they're all congruent to each other. So this is an equilateral triangle. Now let's go on to our next examples. We can also identify them by their angles. If we look at this angle, for this procedure, we always look at our largest angle. So we always look at our largest angle. So I'm going to actually go through each image and circle my largest angle. If your angle is less than 90, you have an acute triangle. If your angle is equal to 90, you have a right triangle. And if your angle is greater than 90, you have an obtuse triangle. So if we look at this image right here, we have our largest angle is 80. So we have to ask ourselves, is 80 smaller than 90, equal to 90, or larger than 90? Well, we know 80 is less than 90. So this is an acute triangle. Now let's go to our second triangle. If we look, our largest angle is 90. So we know it's equal to 90, so this is a right triangle. And then last but not least, we have a 99 that's larger than 90, so this is an obtuse triangle. And then a quick fast fact. When I tell you a fast fact, I mean you need to know this fact cold. The sum of the interior angles of a triangle is 108 degrees. So that is going to be our big feature. The sides don't add up to 180. The angles add up to 180. Okay, question number 1. The degree measures of the angles of a triangle are represented by x, 3x, and 5x minus 54. Find the value of x. So the first thing we're going to do is we're actually going to draw an image or a triangle, and we're going to put our angle measures in. So we know that our angle measures are x, 3x, and 5x minus 54. We know that when we take each of these angles, add them up and set them equal to, we can add them up and set them equal to 180, because we know that the measures of the angles will add up to 180 degrees. So what we're going to do is we're going to take our x, we're going to take our 3x and our 5x minus 54, we're going to add them together and set them equal to 180. So our equation is going to look like this. So the first thing we have to ask ourselves, do we have parentheses? Nope. Can we combine like terms? Yup. I can combine my x, my 3x, and my 5x. X plus 3x is 4x. 4x plus 5x is 9x. So I have 9x minus 54 is equal to 180. I need to ask myself, how do I get rid of that minus 54? I'm going to add 54 to both sides of my equation. So my 54's cancel. So I get 9x equals 180 plus 54 is 234. And then I have to ask myself, how do you get rid of that 9? I'm going to divide by a 9. So I get x is equal to 26. And that's your final answer. Because the question's not asking you for an angle, it's just asking you what x is equal to. Let's go on to our next set of examples. Right triangles and angles. Please, please, please remember that a right triangle must have a 90-degree angle. So in some of these examples, you're going to see that it will just say, oh, I have a right triangle, or the acute measures of a right triangle measure this. Please, please, please make sure that you remember that triangle has a 90-degree angle. So let's read question number 3. The acute angles of a right triangle measure 2x plus 1 degrees and x plus 8 degrees. Find the measure of the angle. So the first thing we're going to do is we're going to draw a right triangle. Again, Mr. O'Sullivan is not an artist. And we have a 90-degree angle right here. I'm going to put my 2x plus 1 and my x plus 8 in. And if you look, I have 3 angles, and I know when I add them up, they're going to be equal to 180. So I'm going to take my 3 angles, add them up, and set them equal to 180. It says find the measure of each angle. So I have my 2x plus 1 plus my x plus 8, and I also have this angle right here, which is 90 degrees. And that's equal to 180. So what we're going to do is we're going to combine our like terms. So my 2x plus x is 3x. I'm now going to combine my 1, my 8, and my 90. 1 plus 8 is 9. 9 plus 90 is 99. So I have 3x plus 99 equals 180. The next thing I need to do is get rid of my 99, so I'm going to subtract 99 from both sides of my equation. And I get 3x is equal to 180 minus 99, which is equal to 81. I now need to get rid of my 3, so I'm going to divide both sides by 3. And then I get x is equal to 27. Thing is, the question's not asking me to solve for x, it's asking me to find my angle. So I now have to go back into my image and find the value of each of those angles. So I know I have a 90. That's my final answer there, because it says find the measures of the angles. I have a 2x plus 1, so what I'm going to do is I'm going to go right here and do 2 times 27 plus 1. 2 times 27 is 54. 54 plus 1 is 55, so I have a 55-degree angle. And then right here, I just do 27 plus 8, which is 35. So I get 35 degrees. And then by boxing that, I know that you know what your angles are. Okay, let's look at isosceles triangles and angles. Isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite the sides are congruent as well. So remember, we know triangles have 180 degrees. And with isosceles triangles, we have this. Congruent sides and congruent angles. Well, that sort of looks like the Angry Bird and Angry Birds. Just a little side note. So find the measure of the unknown angles. So we know that we have 180 degrees. We know that this side and this side are congruent because that's what the image is telling us, which means that this angle and this angle are congruent. So if this is 75, this also has to be 75 degrees. Here's the issue. I now want to find this angle. So what I'm going to do is I'm going to do 180 minus 75 minus 75. When I type that on my calculator, I get 30 degrees. So my missing angle right here is 30 degrees. For this example, I know that these two sides are congruent. So I know that this angle and this angle are congruent. So there's two ways I can do it. I'm just going to focus on one way. I know that there is 180 degrees in a triangle. So I'm going to do 180 minus 70, which will give me 110. So I know that this angle and this angle have to add up to 110. So what I can do is I can just take my 110 and divide by 2, which will give me 55 degrees. So this angle and this angle, or my question marks, are 55 degrees each. Okay. In isosceles triangle ABC, the vertex angle is 20 more than twice the base angles. Find the measure of all the angles. So the first thing we're going to do is we're going to draw a picture of triangle ABC. The vertex angle is 20 more than twice the base angles. So in this case, I don't know what my base angles are, so if I don't know something, I'm just going to put an X. I know my base angles are congruent to each other. So 20 more then is addition. Twice is 2x. So I have 20 plus 2x. I want to find the value of each of those angles, so what I'm going to do is I'm going to take each of those angles, add them up, and set them equal to 180. So I have x plus 20 plus 2x equals 180. So combine those like terms. X plus 2x is 4x. Plus 20 equals 180. I now need to get rid of that 20, so I'm going to take away 20 from both sides of my equation. I get 4x equals 160. Now I need to divide both sides by 4. And I get x is equal to 40. But here's the issue. That's not my final answer. My final answer is the angles. So I now have to go back in and plug it in, which is actually going to be pretty quick. This angle is 40 degrees. This angle is 40 degrees. And this angle is 20 plus 2 times 40. 2 times 40 is 80. 80 plus 20 is 100. So I got a 100-degree angle, a 40-degree angle, and a 40-degree angle. And that's your final answer. Number 6. The lengths of the sides of an isosceles triangle are represented by 2x plus 5, 2x minus 6, and 3x minus 3. What are the lengths of the sides of the triangle? So this one's actually a bit of a guess and check. So when we do this one, we don't know which sides are equal to each other. So we're just going to draw a generic triangle. And we're going to put our 2x plus 5, our 2x minus 6, and our 3x minus 3 wherever. We typically set the sides opposite each other equal to each other. So I'm going to set my 2x plus 5 and my 2x minus 6 equal to each other. When I set them equal to each other, I need to get all my x's on one side and numbers on the other. So I'm going to take away 2x, take away 2x, 2x's cancel. Oh no, I get 5 equals negative 6. Is 5 ever equal to negative 6? No. So what that's telling me is that these two sides are not equal to each other. So now we're going to have to try a different pair of sides. So I'm actually going to try now my 2x plus 5 and my 3x minus 3, and let's see if that works. So I want to get all my x's on one side, numbers on the other. I'm going to take away 3x, 3x. So I get negative 1x plus 5 equals negative 3. Take away 5, take away 5. Negative 1x equals negative 8. And then divide by a negative 1. So I get x is equal to 8. Let's see if that works, because now we're going to plug it in. So I know in an isosceles triangle, I've got two sides that are equal to each other. So what we're going to do is we're going to plug it into each, and if we get two equal sides, then we know we did it correctly. So So I'm going to plug in my 8. So I get 3 times 8 minus 3. 24 minus 3 is 21. 2 times 8 minus 6 is 10. And then 2 times 8 plus 5 is 21. So this is an isosceles triangle, and we made it work because we have 2 side lengths that are 21 and 1 side length that is 10. Okay, let's go into this next challenging question. Someone read it for me. Oh wait, this is actually a recording, so no one can read it for me. Okay, so the perimeter of triangle ABC is 36 if angle A is congruent to angle B, AB is x plus 3, and AC is x. Find the value of x. So perimeter, that's when you add up all your sides. Not angles. So what we're going to do is we have an isosceles triangle, triangle ABC. We know that angle A and angle B are congruent to each other. So we know AB is x plus 3. AC is x. The thing is, if angle A and angle B are congruent to each other, their sides are congruent as well. So this is an x as well. We know our perimeter is 36. So what we're going to do is we're going to take those sides and set them equal to 36. So I have x plus x plus x plus 3 equals 36. Combine your like terms of x, x, and x. I get 3x plus 3 equals 36. Take away 3 from both sides of my equation. I get 3x is equal to 33. And then divide both sides by 3. And get x is equal to 11. And that's your final answer. All right, that's it for today. Don't forget to complete your delta math. Have a great day, ladies.